Talk Python to Me, episode number 4, with guest Mahmoud Hashemi, recorded Tuesday, April 7th, 2015. You may have noticed that we have new intro music for this show. If you're a fan of the Developers music by Smix, don't worry, he's not gone. He'll be back next time. However, I chose this music for this show because it's actually not a performance, but rather sounds from an auditory experience for Wikipedia called Listen to Wikipedia. This is a project written in Python by our guest, Mahmoud. We'll talk a little bit about that during the show. The sounds you hear corresponds to edits, additions, and deletions to Wikipedia. Reading off a few of the topics that cause those sounds are kind of random, but here they are. Asphalt, Geography of Peru, Subobject, Fox, 2013 European Olympics, Pretty Little Liars, and Carrie's Grammar School. If you need some sweet Zen sounds to program to, or are just interested in this project, check it out at listen.hatnote.com and experience Python and Wikipedia and audio all wrapped up into one for yourself. That's listen.hatnote.com. Now, on to the show. Hello and welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystems, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy, and keep up with the show and listen to past episodes at talkpythontome.com. This episode we'll be talking to Mahmoud Hashemi about enterprise Python and large-scale Python projects. Mahmoud Hashemi is the lead developer of the Python infrastructure team at eBay and PayPal, where he focuses his development and instruction energies on service frameworks, API design, and system resiliency. Outside of work, he enjoys coding on his open-source projects, which you can find at github.com/Mahmoud, as well as creating and maintaining several Wikipedia-based projects such as Listen to Wikipedia and the Wikipedia.
You got it.
Excellent. Mahmoud, welcome to the show.
Oh, yeah, thank you. It's great to be here. Like I said before, I'm a very big fan of the prior two episodes, just listening to the MongoDB episode on my way here today.
Oh, that's fantastic. Yeah, we just released that like a few hours ago. It was great.
Yeah, it popped up on my phone. I listened to it right away.
All right, so it sounds like you have some amazing stuff going on with Python at PayPal. And, you know, the way that I sort of got to know you, I just ran across this blog post that you did called 10 Myths of Enterprise Python. And I was seriously blown away at the detail and sort of the power of your message that Python is this really fantastic, powerful, flexible, and, you know, surprisingly to some people, not to me, but to some people, large-scale development platform.
Well, and I mean, I don't know what took me so long, honestly. Like that post, you know, we were looking for that post years ago, and like when we were just starting to evangelize Python and like work on Python here at PayPal. But you know, like it was like scattered throughout the whole internet. The evidence was there. I was just looking for something that summed it up in that, like, you know, very sort of like modern internet fashion. But you know, and then I guess like I think I wrote the first draft of this maybe like a year ago and started using it in internal presentations and so forth. But I mean, yeah, we really did need it something like 4 or 5 years ago. And what is that quote? You should be the change you want to see in the world. And
exactly.
Like eventually, like, you know, I just went through the whole process to get onto the corporate blog and like just get it out there to help, like, you know, anyone else who might be in the same sort of bind. You know, just looking for like a comprehensive set of evidence to sort of quash these very persistent arguments that seem to be coming up in, you know, the sort of corporate meetings that we all know and love. So,
yeah, and what I really love about your article is it's so full of evidence. Like, you know, every sentence, at least every paragraph has a couple of links to other sort of richer articles that back up whatever it is you're talking about. That's great.
Yeah, and I mean, So I mean, that's the thing. It's like I don't even really feel like that responsible for all of this. All of the evidence was there. It just needed to be collected under one roof, and then hopefully have some sort of credible source to it. I mean, the real like seller for me here at PayPal is often that Bank of America has thousands of Python developers. You know, that's a financial institution, arguably like much more important and larger than PayPal. And they like trust Python with all sorts of like activities. So if it's good enough for them, it should be good enough for us. But the thing is that that's like not really advertised that much, even though they're at PyCon, like doing recruiting, looking for people. If you're looking for a job, maybe call up Bank of America. So yeah, I mean, we'll go through them one by one here, I guess, today. But for the most part, I guess I came to write that blog post by way of originally joining PayPal as a PHP developer. Not for PayPal, mind you, but that was just what I knew. Like coming into the company, I saw that there was sort of this. It was like code archaeology, if you would, right? Like there was some evidence of Python usage dating back to the early days of PayPal.
You said prior to HTTP or something like that, right? And prior to Java, quite a way back.
Oh, yeah, no, way before. So I mean, basically, when original PayPal was all C++, and I think still majority of the traffic in the data center is going between like C++ services and so forth. So yeah, I mean, there's a long history here going back to like 1998. Pretty much when I came, like sort of that ancient civilization was for the most part gone in 2008, 2009.
Where had it moved to? What were people using?
I mean, people went and founded YouTube and Yelp and LinkedIn and used Python to much, more visible good than I guess probably has come from my own role here at PayPal. But it's all has to start somewhere.
Yeah, that's pretty amazing. Like I was telling you before the show, I just talked to the Chris McDonough from the Pyramid guys, and he said that also Pyramid is being used at Yelp. So a lot of things coming together in these two shows. That's really cool. I think YouTube is really one of the major sort of things we can put up on a pedestal and say, before you say that it can't, look at this and see if you could build that with whatever your pet project or pet technology is. And another one is Dropbox. Those guys are really doing interesting stuff, especially with Guido moving over there full time, which is pretty cool.
Yeah. It's pretty neat the way the sort of like energy inducing effects he has when he sort of like moves between these companies. Like he was previously at Google and worked on App Engine there and was I guess like probably a very key probably subconscious influence I would guess in in Python becoming sort of the third stack there at Google.
Yeah, that's really cool. Michael here. Thank you so much for listening to and spreading the word about Talk Python to me. The response to the podcast continues to be wonderful and humbling. I have a quick comment about supporting and sponsoring the show. I'm still looking to line up stable corporate sponsorships, but I wanted to tell you about a community-based campaign I'm launching to allow listeners to directly support the show. We are running a Patreon campaign. You might not have heard about Patreon, but it's kind of like Kickstarter for things like podcasts, which release frequent small deliverables rather than one-off large engineering projects. Visit patreon.com/mkennedy, that's patreon.com/mkennedy, and watch the video to see how you can donate as little as $1 per episode to support Talk Python to me. This is your chance to ensure that the Python community continues to have a strong public voice. Consider supporting us today at patreon.com/mkennedy, and thanks for listening. So before we move into the myths, let me just ask you, how did PayPal and eBay sort of adopt Python so broadly? So, So there was this history, and then some of those people kind of moved on to do, minor things like YouTube. And then, and then it sounds like you guys are doing a lot of Python stuff now, right?
Oh yeah, absolutely. So, basically every aspect of PayPal, and it is like a large business with many different concerns. So every aspect you can name, we basically have some contingency of some contingent of Python in that group. So whether it is data analysis in the risk group, or it is let's see, I'm trying not to give away too much here.
Yeah, don't spill any super secret things you can't talk about, but
admin tools, batch jobs, mid-tier services, even some web development and web service front-end type stuff is going on as well, even though it's primarily shifted to other stacks at the moment.
Sure. Okay. Well, that's really interesting.
Mm-hmm.
I think that's a nice lead-in to sort of some of the myths. So on your post, you say that you have actually over 50 Python projects running there at PayPal, eBay, and you sort of go through a list of all the different kinds of things. How many people are working on these projects, and are they all active, and what's the story there?
Well, Python is sort of kind of renowned for being able to let you move fast. And it's interesting how one Python developer can sort of sweep through his new team or his new organization and fix a whole lot of things and get a whole lot of balls rolling. The 50 plus number is really definitely immediately attributable to Python's own high efficiency.
Right. It's easy to start and complete 50 projects, more so than, say, C++ or something like Java.
Right. I think one developer in 2014 got something like 3 services launched on the eBay side using some of our new cloud integration stuff. And that's just one guy. He's a team of one. And so...
The meetings are short.
Oh, yeah. So basically, when I started out, there were maybe... It started with me making a DL or sort of having an email list on a listserv, and I think maybe 25 people joined up, right? And then I think now the DL has on the order of 260 people who use Python on a somewhat regular basis, and I can't take much. I can't take all the credit for this because a lot of it is due to the sort of burgeoning OpenStack wave. eBay is one of the main contributors to OpenStack, main users of OpenStack. PayPal has also followed suit there, and then also we've done some acquisitions, of companies that use Python pretty heavily. So it's sort of had a lot of organic growth. I'd say most of the growth is organic, but a lot of it is also attributable to those external projects as well.
Yeah, sure. So some of it came from the outside and sort of pollinated the internal folks, right? Something to that effect.
Right, and that's why I think it's really important that PayPal and eBay sort of participate in that open source ecosystem so that they can continue to derive benefits from that, as we've seen in the past few years here.
Yeah, do you guys have a corporate GitHub place where you're doing things or anything like that?
Absolutely. GitHub.com/eBay, GitHub.com/PayPal. I don't personally maintain the Python SDKs by any means for these companies, but I do know the maintainers quite well. So I'm willing to take some email spam if you want to email me at mahmood@paypal.com. And I'll forward your messages on to the folks in charge of those. But they also are pretty responsive on GitHub issues. And all in all, I think that these Python developers that are in our GitHubs are pretty much on the ball when it comes to the whole open source philosophy.
That's cool. Can you open an issue on GitHub for the team? Yeah. Okay. Very cool. So you can participate there.
Even the Python infrastructure team, who was mostly an internal team, now has a repo up there. It's a mid-tier server framework. It can be used for frontier as well, but we primarily use it here for mid-tier stuff. And it is called support. So you just go github.com/PayPal/support, and hopefully you'll see me updating the docs.
Fantastic.
Fervently. Yes.
That sounds really cool.
Mm-hmm.
So you want to touch on some of the myths?
Absolutely, that's what we're here for after all.
Yeah, I think there's probably 50 myths if we sat down and brainstorm over enough beer and over enough time. But
it's true. I had to cut it down to these 10.
But I think you really did hit some interesting ones. And maybe this is just my sort of myopic view of the world, but to me it feels like Python is becoming quite a bit more popular in the last 5 years than it has been.
Yeah, absolutely. And I think that is what is leading into what I think I had as myth number 1, which was that Python is a new language.
Exactly. People are just now starting to hear about it. They feel like, oh, this thing's taken off, but it's not new, is it?
Yeah. No, I mean it's technically older than Java. Its first release happened 3 years before the first release of Java, and I mean it comes from like a really long history as well. Like it's not just So it's not a sort of like designed in a week kind of language that just like appeared out of nowhere. It's based on like Guido's long experience with languages like C and ABC.
Absolutely, and I think he took like 2 years. He started in like 1989, maybe I seem to remember, and it came out in 91, version 1.0, something like that.
Yeah, well, I was just a wee one, right? Exactly. Like running around, not even thinking about like programming. But yeah, it is it is a very mature language on top of that. And I mean, I don't think I go into this in the post, but it has evolved so remarkably. Like all of the changes after like version 2.2 with new style classes and all of the rationalizations that have occurred have really like proven that it still has the flexibility of a new language, right? Where it's constantly under development. And you can see a lot of that in sort of like the interesting sort of like discussions and tensions that arise, with the Python 3 issue.
Yeah, the Python 2, Python 3 issues. We probably have to have a whole show on that. But, it is... I actually have some opinions on that. But, I think it's interesting how much the language is still sort of evolving in a positive way. So, for example, in 3.3, they had added yield from to simplify generator methods, which was really cool. In 3.4, they added async IO. In 3.5, there's talk of like type hinting. I mean, these are major sort of additions that are coming on still with 25 plus years out.
And many of them have a really nice, realistic timeline to them because, Python 3 adoption, it'll take some time. You'll probably need a whole show on that, and you'll have plenty of time to get it out before Python 3 is the majority. But yeah.
The debate will still be raging if we have that show in 6 months, I'm sure.
Absolutely. So, yeah, but, I mean, Python is not a new language, and probably most of the people on this show, or who will be listening to this show, are going to know that, I think.
Absolutely, but one of the goals I kind of have for this show is, obviously, the people that take the time to, sign up and listen to a Python podcast generally are knowledgeable about it pretty well already, but, maybe they work in teams where people aren't. I have a lot of conversations with folks who are in sort of the more compiled language space, and they always think of, Python is like this scripting. It's almost like it's a bash shell script type of thing. And I don't think they appreciate sort of basically what you laid out in your 10 myths here, which is really cool. So speaking of a compiled language, that's myth number 2, right?
Well, sure. And so myth number 2 is that Python's not compiled. This one is a little bit of a, it's a little bit of sort of a leading myth in a way. People do sort of bring this up, but the point is that what they're trying to say is that Python is not like C++ and Java. I mean, it just ends up coming up always. At a company that uses primarily C++ and Java, we're going to have a lot of people who sort of protest at the first time they're seeing a REPL used effectively, right. When you're doing a live demo or something like that. So they say what do you mean there's no compilation? What happens if I get something wrong? And it's well, you got tests and you'll be okay. So Yeah, Python's not, and the other thing too is that Python is technically compiled. Like it does get compiled down to bytecode. It happens fast enough that it can happen sort of like, right before runtime without incurring too much of like, overhead for most sizes of projects.
Right, and it does cache that output as the PCH is, right, in the PyCache or whatever it's called.
Right, the PYCs and the PyCache in Python 3, yes. And so, so basically it is a compiled language, and it does execute from bytecode, which is exactly what Java does. And I mean, the JVM also suffers from a thing called type erasure, which not sure if I mentioned this in the post. It probably did, but yeah, it has type erasure because it's originally based on a Smalltalk VM, which Smalltalk itself isn't really a statically typed language. So basically, effectively, the bytecode that's emitted by Python is kind of on the same level as the bytecode emitted on the Java side. And the main difference between those two runtimes is the JIT, the just-in-time
compile. The JIT and the GC. That's interesting. Yeah, the most notable thing that comes to mind when you say that is sort of the Java implementation of generics or templates, where in the language it looks like it's, integers and other types of objects, but it's really just, down to object at the base, right, when it runs. The other thing I think is interesting about this is I'm sure one of the hesitations is, what do you mean you're going to give just the source code away as bare files, right? And, Java and .NET and those things, they don't protect you much, right? Because all you got to do is throw into a tool and you see basically the same thing.
Absolutely, and rely on that for security, whatsoever.
So yeah, it's interesting that these other languages can be decompiled, and so in some sense, you're more or less giving away your source code as well. And although there are obfuscators, if you really want to get to it, it doesn't matter so much. I think that brings us to the real, actually important matter: is Python secure or not?
Yeah, that's the real question that people should be asking, rather than wondering if they should distribute source code. Is Python secure? To which the answer is yes, definitely. To the point that we're willing to actually put a lot of our security onto that platform. And it's not just our own assessment. There have been studies done, surveys done of the actual Python source code that determined that it was actually very safe, not really prone to many of the traditional sort of C the C runtime issues that can occur that we've seen perhaps in OpenSSL and so forth.
Right. A lot of the safety of the language, the fact that you can't work with raw bytes and pointers and offsets, is part of it. Then also you also pointed out that the small surface area, you can accomplish so much with so little that you don't have to kind of put so much out there in your code, so it's easier to guard that smaller code base.
Right, and that's just a good security policy, general good security policy. So, but no, specifically, when we were having our discussions about security, using Python with security here at PayPal, we did talk about the implications of using CPython and CPython's maturity, as well as the code analysis that has occurred on it, was one of the deciding factors. Basically, if you look at Java or something like that, every couple weeks there's a new Java update because it has tried to introduce a new security model into its runtime involving protected memory and that sort of stuff. So maybe I should rephrase that. Basically, it makes promises that are hard to keep, and so they end up having a lot of security releases. You don't see those same sort of security releases nearly as often as CPython, even though it has a very wide usage. It's on not only all the servers, but also most of consumer computers at this point.
Right, definitely all the Macs and Linux machines anyway.
Exactly. So if it were a viable sort of attack, if it was sort of a viable vulnerability, if you would, it would probably be exploited by now. And so it's and you can never really prove security. You can just sort of go with what seems to be secure. And the way that you get a good idea of that is something that has been as widely tested as Python.
Absolutely. Yeah, you cannot prove security by one example where a person's not hacked, right? But
right.
More and more that it sustains up over time, the more faith we should put in a system. Absolutely. So I think number 4 may be my absolute favorite, or at least the most encountered one for me, the folks that I interact with, and that's Python is really just a scripting language.
And this is the original myth, in my experience.
I agree.
Yeah. So, I mean, when I was giving my first tech talk, I remember it like it was yesterday. After I finished, we were demoing a new application that basically controls the prices of PayPal. It's still used now. It's like before this application was released, it would take on the order of weeks to get new pricing schedules out for like, certain vendors and that sort of stuff. And this made it so that it became just a matter of like hours or minutes. And so we were demoing all of this, and by the time we got to the end, the first question out of the first person's mouth was, so wait a second, you did this in Python, right? And I'm like, oh, well, yes. And how do you mean? And they're like, but Python is a scripting language, so what is this? Is this like CGI, or what is this? Like, how is it that you're like talking these complex network protocols with a scripting language? As though I had done something very irresponsible. But I mean,
really funny.
4 or 5 years later, here we are, and it's still like doing a bang up job. So
yeah, that's fantastic.
Yeah. And so in this myth, I like basically go through, as mentioned like earlier in the program here, like, I go through all of the different like companies that have used Python in so many different ways. It is a general purpose language as it describes itself. So it has many, many purposes.
Yeah, I really like your list, and maybe I'll just read a couple of them. So we've got like Twilio doing telephony infrastructure, obviously payments with you guys, neuroscience and psychology, with tons of examples. There's all the numerical analysis stuff with NumPy and SciPy. Disney, DreamWorks, and LucasArts are all doing animation rendering type stuff, games, backends, email. Let's see what else is here. I think the security and penetration testing stuff is interesting. Big data, Hadoop, and then obviously we just talked to the Mongo guys. There's great support on those types of systems.
Yeah, and we're spinning up a Disco cluster here too. Disco's been around for like a little while, but it's sort of like an Erlang and Python-based big data thing. We're spinning up a cluster here. It's actually been a pretty interesting experience so far.
Oh, I bet that's an interesting thing to work with.
Definitely. My favorite example of all of this, right, was sort of during sort of a contentious time in the Python infrastructure team's history here. I think Bind 10 came out and announced that they were going to like use Python for a good part of DNS. Right, which is basically as close to infrastructure as like common infrastructure as the internet has. So, I'm not sure where that's at right now.
Yeah, that's pretty cool though.
Yeah, but it was like a really like sort of it drove a stake through the heart of this myth that Python's just a scripting language.
Well, I think one of the other concepts that leads to people thinking that is, well, you can't have a real language without strong typing, and so people think Python is weakly typed, right?
No, that's so this is another one that I guess people like, in a practical meeting start getting into theoretical aspects, right? And they start getting into type systems, which Python is definitely a language of like sort of pragmatic doing of things. And so that's my way of saying get shit done. I'm not sure what rating you have on this podcast, but and people will bring up that it's weakly typed, and to the response to this, the real response to this should just be like, one, it's not, and even if it was, like, so what? Like, the thing has already been done by the end of the meeting, so it's really about getting like results. And Python's type system, while wonderful, I'm a very big fan. Has very little to do with it's. Well, is that? I don't want to rule it out. But I like in a moment there.
JavaScript is an example that you could actually do without real typing and still get stuff done. The Node guys and so on.
It's true. I don't know if I include that one, but yeah. So it's true though. Python is like a strongly dynamically typed language, and it works for strong dynamic people.
Yeah, that's fantastic. So another myth, people think of the scripting language and they think it's just this interpreted thing. And so, well, obviously interpreted code is slow. And even if you just focus on CPython, I think the performance story is super nuanced and interesting and non-obvious. So, take like NumPy, for example. So if you did all of your sort of mathematics in pure Python and then interpreted that would probably be slow. But of course, they've taken the slow parts and rewritten that in C. So that's sort of native, and that's super fast. And if you can just kind of orchestrate calling into these low-level C functions, then you're talking about really fast even C Python, but there's more to it than that, right? There's a ton of runtimes or implementations.
Definitely. I mean, Python's demand has led to quite a bit of supply in all sorts of different aspects. Runtimes definitely being one of them. So, I mean, you've got CPython, which is the standard. You've got Jython and IronPython and PyPy, and then there are more sort of academic ones that, for teaching how a runtime works and so forth. So. But the real key here is that calling it an interpreted language is sort of a form of micro-labeling that doesn't actually contribute to the overall engineering discussion that it should be happening, which is that Python can have such a huge impact on your workflow. So yeah, you can iterate on your projects at such great speed that you end up finding yourself using more advanced techniques, or finding out that this area that you would have spent so much time optimizing otherwise is actually not really where the majority of the work of your application is being done. So basically it allows you to focus on what matters. When you take that to a macro level, looking at the whole ecosystem, there are people out there who have gone through that same workflow and have generalized out libraries that you can then take advantage of all of their optimizations. So, instances where Python has ended up using SIMD, which is sort of vectorized, computation that would otherwise be rather difficult to code by hand in C and C++, not to mention distribute. Yeah, I mean it's really important to look at the whole process instead of just individual adjectives about how a given single runtime works. The Python way will lead to faster and more efficient code, that makes a big difference on the overall complexity of your application, which can lead to better maintenance aspects as well.
Yeah, that's really interesting. I've talked with some companies that are doing amazing stuff and sort of building their almost entire enterprise foundation on top of Python, and they've got the group I was speaking with. I can't, it's NDA stuff. I can't really talk about it, but they had 160 internal enterprise business applications, and they were creating a Python layer to be the foundation of sort of unifying all that data and underlying infrastructure. And if you could do that, then you can do some pretty amazing stuff. That's not a slow system you decide to do that with.
Yeah, and I mean, with honestly, enterprise is not sort of the domain of performance being king. We end up spending more time than we should talking about it because I guess people want to go back to their college roots. But honestly, we can afford more machines. We put more machines on it because we need the redundancy anyway, right? And we end up having to spend. We should spend more time talking about just how our developers interact with our development tools, because that's really usually where we have a bigger bottleneck, actually getting projects done on time. If you do it in Python, you end up having extra time. You can engineer your products for correct behavior, and you profile it. Python has decent profilers built right in, and then you can optimize it as need be. And we've even found spare cycles to write some of our hot loops in C.
Yeah, maybe even have some time to write some unit tests to make sure it works right when you have
Yeah, no, quality is what lets us sort of sleep soundly at night. That's what's going to actually make for successful business in the long term, generally speaking.
Right. So that was myth number 6, which was that Python is slow. And I think you have kind of a pair of myths that talk about scaling. And one of them is number 7 is Python does not scale. And you have some really interesting examples on sort of performance scale there.
Well, yeah, because this one is just so easily quashed by counterexample, right? YouTube, I think, is the second largest website on the internet right now, right? We talk about Dropbox, Discuss, Eventbrite, Reddit, right? Then we have Twilio with the telephony, right? And Instagram and Yelp, and I mean, even games, right? EVE Online and Second Life, right? They're actually the areas where you find the most radical scaling stories, because unlike enterprise companies like PayPal and Bank of America, they're not made of money, right? The game has to be fun, and they run a tight margin, and they do it for the love of crafting a unique sort of self-contained system. And they end up creating such technology marvels as Stackless and Eventlit and all that sort of stuff. So
Well, stackless and eventlet and, Tornado, async IO, all these sorts of things are sort of in the general realm of concurrency and async processing. And that's your myth number 8, right? Is that Python, that it does lack good support for sort of concurrency and multi-threading.
Yeah, so this one I think is one area where Python probably gets the most legitimate technology flack, and that's because I would say that's because Python sort of has a stated mission of there's only one obvious way to do something, and in the realm of concurrency, unfortunately, that's not true. So CPython, by itself, is sort of a runtime environment. When you introduce a concurrency sort of library to that, you change your fundamental runtime behaviors. You basically have added a layer on top of CPython's sort of native main thread or whatever you want to call it. Now either you're working with threads or greenlets or promises or deferreds, and that really there are so many different opinions that you can have about that area of computing that Python has itself spawned, I think probably at this point a dozen different ways to do concurrency.
Right. I think one of the things that people immediately jump to, some people anyway, when they hear I need more concurrency is let me kick off a bunch of threads. And I think better or worse, the whole Node.js thing that's was really popular sort of coming up a few years ago is showing that you can get really great concurrency with very, very few threads if you're willing to sort of put those threads, reuse those threads when they're generally waiting on a web service call or a database call or disk IO or something like that, right?
Yeah, absolutely. And I mean, it's been really amazing how we've sort of rediscovered these techniques. One of the guys on the Python infrastructure team here actually worked on the AIM servers, if you remember AOL Instant Messenger. And that was all, and they did it all with C and callbacks, and they actually we end up doing a lot of the stuff that he did back in the day. We end up redoing that sort of now. It's been really nice having sort of a graybeard, if you would, around because basically he sort of I think back in the day he was working with SSL BIO and OpenSSL's BIOs, and today we're doing sort of the same thing. And back in the day they also had trouble with threads, and these days we still find trouble with threads. And these aren't Python specific troubles. It's just that threaded programming bears a few risks. And so in our infrastructure anyway, we've sort of we've made some decisions for our developers that will allow us to pre-mitigate those risks, And one of those is to basically sort of limit ourselves to a somewhat fixed number of threads. You don't want to have one thread per request, for instance, in a server, because that means that as your load goes up, your contention and overhead sort of also start going up.
Sure, yeah, and even just the pure memory from just the stack space for each thread can start to become significant when you're talking tens of thousands or hundreds of thousands of threads. It's a problem, yeah.
Right. And so what we end up with in a lot of cases for applications that have gone with a threaded model, and these aren't Python applications, they end up topping out with sort of a hard stop. They start falling behind on their work without being able to respond and shed load nicely. We can sort of chalk up all of our good server behavior to just having the time to actually analyze how our application works, add additional sort of behaviors, and instrument it appropriately, because we're not spending all of our time wrangling with a thread per request model or. But you really do have to. I mean, going back to the original issue of concurrency support, a concurrency library is more than just any other library, because you end up having to adopt some aspect of its philosophy, and there aren't any real easy answers there. You need to look at what they are, find out what is easily digested by you and your brain, and then look at examples of how other people have architected their applications if you don't have strong opinions of your own. It's a learning process, and this is something I feel that maybe they should spend more time on back in most schools, where unfortunately they mostly just focus on processes and threads, which, while important, aren't the whole story.
Absolutely. Well, maybe that's changing in the future. A friend of mine has a really interesting saying or way of looking at the world. He says, look, when you're writing this multi-threaded concurrent code, if you try to get too tricky, you're writing code right at the limit of your ability to understand what you're doing. And debugging code is harder than writing code. So you're writing code that you literally can't debug. You know what I mean? Like you've just gone right over that barrier. Now it's like, I've created this monster I got to live with. So that's pretty interesting.
And I mean, the code certainly takes on its own, a soul of its own. But like basically when you start running it at scale and it's spread across many pools of many machines, like it ends up like having an almost organic nature when you take into account like load balancers and like, you know, variations in the network and so forth. You need to make time for all of those sort of emergent behaviors that are going to come up when you deploy.
Yeah, absolutely. So myth number 9 is that Python programmers are scarce.
Like I think I mentioned in the myth that like this is somewhat true, right? It depends what you're comparing it to, though, but like I said before, you know, we have one developer that goes and creates 3 production services in 1 year.
Right? Do you need a huge team of Python developers to accomplish some project? Maybe not.
Yeah, maybe not. Actually, almost certainly not. Almost certainly not as many as you would need for other stacks, and that's sort of reflected in like every Python team that I've seen. Not just here at PayPal, but also like across the industries, that like they end up generally being smaller and more effective. And if you like, the literature sort of backs up that these are actually not bad things to have. People worry about people getting hit by buses, and it's nice of them to be so concerned. But really, like one of the keys with Python is that you can learn it very quickly. And it has a really nice learning curve. I mean, maybe it's just me, but I had a really nice time transitioning from PHP to Django, digging deeper into the standard library, reading the source code of just sort of like modules like itertools and collections and these sorts of things, and learning about Python from examples that are not opaque like they were in C++ and Java. I felt that those those sort of stacks were more opaque and Python was more open. And then, with the rise of GitHub and so forth, going and learning, the fundamentals of web frameworks from Bottle and Django source code, and basically, it sort of has a natural learning curve to it that basically, without any of official training or standard training, we were able to rise to the level of effective infrastructure engineers.
And I had a similar experience, when I first learned C++ way back in the day. I remember it was this mountain I climbed, and learning Python, I mean, obviously learning it as a second language makes it a next language, not the first language, makes it easier to do. But I think even if I had learned it originally, it would have been a much more enjoyable experience. So, and then, you make some interesting points about, well, there may be not so many Python developers, or however many there are, there's going to be more.
Yeah, and I mean, especially when there are changes happening in education right now, where Python is becoming I think the top teaching
exactly.
language.
That's what I was thinking of. Is that just the last couple of years ago, it flipped, I think, from Java maybe into Python being the most taught programming language in college. So a little while that will have some big effects,
Yeah, and already we're seeing it. I mean, if your company has a policy that they'll for a while, PayPal had a policy where they would only hire experienced engineers, not straight out of college. But already we're seeing people coming out of college being hired at PayPal whose primary experience is in Python. So the effect is already there. And I mean, frankly, of course, I think it's a good thing, but especially because Python has so many language features that are so well documented and well thought through and designed through PEPs and the Python enhancement processes. So I mean, it's just a more open, approachable language that has so much to teach. That even if you're going to end up working in other languages, I recommend studying Python, unless it's going to spoil you for other languages, which has been known to occur.
If you don't want to go to work anymore because you have to go back to writing embedded C, you may want to stay away from Python. That's right.
We like C. We like C too. Anyways.
Okay, so I think your final myth actually had some of the most interesting actual statistics in it. That's that Python is not for large projects, as in large number of lines of code.
Right. So, I mean, before we talked about scaling traffic, which YouTube and others clearly disprove, that you can just Python has Python has a consistent, intuitive runtime, and it can scale simply. But scaling the developer side of things is not as simple, right? People are complex. And so, but that said, I mean, there have been many ways, like, examples of Python scaling to the enterprise level. And here at like PayPal and eBay is, we have a lot of small teams, but we have some larger ones too, with like multiple experienced developers and a couple of junior developers and so forth. So on the OpenStack side, especially. So. Bank of America, like I mentioned before, has 5,000 Python developers, and they just spun that out of nowhere. Maybe that's why Python developers are scarce.
Yeah, maybe they grabbed them all up. Yeah, you said they have over 10 million lines of Python code, which is kind of crazy.
I mean, yeah. They did that. I think either they did that because J.P. Morgan was doing it, or J.P. Morgan did it because Bank of America was doing it, or maybe it was just a coincidence. But the financial industry has certainly seen a large amount of Python adoption. And the important thing too is that when your company starts getting big enough, heterogeneity becomes a really important aspect of your recruiting strategy. So, if you really do actually need 2,000, 3,000 developers, then maybe you shouldn't be banking on all of them, being from one programming discipline, right? So basically, with trends in education and open source dictating a lot of what talent is available, you should focus on having language agnostic protocols and well-designed larger architectures that you can plug many languages stacks into. And that's what we have here at PayPal, where we have C++, Java, Python, Node, and there have even been some fledgling work done with Scala and Go. And certainly doing C++ was hard, that built PayPal. Then adding Java was still pretty hard. When we added Python, we actually created reference implementations and standards for a lot of these emergent protocols, and then other stacks can come and sort of follow suit. If there's actually someone in charge of a big project listening to this podcast right now, as long as you have good talent, good architecture, you can definitely use Python as part of a large project. We have many processes detailed in the blog post that can lead to good practices, best practices for a variety of environments.
Yeah, that's great. You talk about static code analysis with PyFlakes and other things like that.
Mm-hmm. It's a big world out there. It's a big industry, and Python has a long history and a lot of experience that it can bring to enhance basically any a company of any size, if you ask me. It's not all about just evangelizing and, as they say, being religious about a given technology. Python is just a really handy piece that fits into a lot of applications.
Yeah, that's really fantastic. And so people out there listening, if they're sort of having these debates at work or on their projects, and they're I'd really like to use Python, but people keep laughing at me and say it's not, whatever, right? Yeah, I really recommend checking out Mahmoud's article, 10 Minutes of Enterprise Python, which I'll link to from the show notes. And you can share that, or you can share this longer form conversation that we had. So
I just wish I had a time machine so I could send it back to me a few years ago.
Yeah, I can see that. What would you say to your former self at work? I would give him this, this article. That's great.
It really would simplify things, but yeah. And also maybe I'd send some stock.
Yeah, exactly. Of course.
Anyways.
All right. Well, I think that's, this has been a super interesting conversation, and a question I'd like to ask my guests on the way out the door is, so much of Python is driven by open source stuff, and there's so much great stuff on PyPy and GitHub and so on. Do you have a favorite thing that, you maybe want to call some attention to? Favorite project?
I have many favorites. One of the ones that I remember looking at recently and being really impressed with the implementation was it was a very small thing. It's called, I think, NetAdder or something like that. And it was just a library for working with IPs and IP ranges. But, as I'm wont to do, I went and I looked at the code, and it was just really exquisitely implemented. It's for some reason, my mind always jumps to that, because I was as I looked at the code, I was just I couldn't do a better job.
I recently saw some guy, I can't remember who, probably in your neighborhood in San Francisco, being interviewed on Bloomberg News about, they had some sort of museum art set up about how code is art and like the beauty of algorithms, and maybe that's sort of part of it.
That's a Gleetsman. He works.
Oh,
here.
he works with you? Oh my gosh, that's awesome.
Yeah. Yeah, so he was part of one of the acquisitions that we had that used a lot of Python, actually. And so he uses our code internally as well. No, I mean, he's a super active guy, lots of great ideas. I think his name Benjamin.
Yeah,
Gleeson?
that sounds correct. It was literally on TV, so I didn't, save it.
It was a weird crossover for sure. Let's see. But I mean, in terms of open source projects I've been spending a lot of time on, I mean, I've worked a lot on this one recently called bolt-ons. Basically, like, these are sort of things that I wish were built into Python. Like, over the years, I've just sort of accumulated all of these utils. Mm-hmm. Right, that I've seen, like, implementations of in various, like, libraries internally. Right, they're just like, oh, like, why doesn't this exist? They'll throw something together that sort of works for them, but it's not as well tested and generalized. So this sort of like, it's just a meta toolbox. It's like a toolbox of all these tools for, like, toolboxes for working with, like, a variety of different things, caches and strings, and some of them are designed as extensions to iter tools and other built-in like modules. Iter tools was certainly one of, like, I mean, if you ask me what my favorite, like, Python modules were, like the standard library ones, I have a list for sure.
Iter tools is up there. Huh?
Iter tools, collections. I mean, I'm a big fan of the select module. Like, there are just so many, like, good standard library things built right in. That batteries included aspect of Python wasn't just responsible for drawing me to Python in the first place, but it was, like, responsible for what I feel was almost like a postgraduate education in like, programming. Like, it's great. I'm getting nostalgic now. Anyways, so.
Getting emotional about the packages. Okay, so is there any final thing you want to kind of call the attention to for the listeners, or give a shout out to, or anything like that?
Like you mentioned in the beginning, we've got, like, one of my passion projects on the side is I have a little, like, gig. It's not a gig. I don't get paid or anything. It's called Hat Note. We're working on Wikipedia-based projects. Maybe you've seen or heard, like, listen to Wikipedia. Our new thing is like a newsletter that just summarizes all the work that Wikipedians, working on. And so it's called the Wikipedia. You can visit it weekly, like, once per week, weekly.hatnote. It's like the thing you wear on your head and the thing you write to a loved one, .com.
That's fantastic. The other one's at listen.hatnote.com, is that right?
Yeah. And so... And these are all Python-based as well, open source. You can find the code at github.com/hatnote. Those are fun weekend projects that I don't have to hold to.
They don't have to process money, for example.
Right. Yeah. I mean, they are high-quality projects, I like to think, but they don't have to be held to the same standards.
The consequence of failure is lower, which makes them maybe more relaxing to work on, yeah.
You nailed it. You got me.
I think that's a wrap. Thank you so much, Mahmoud, for being on the show. This has been a super interesting conversation.
My pleasure.
Yeah, and I think the view inside to some of these big companies, like, it really might give people a different perspective on Python. So I hope so anyway.
Thank you. Yeah, it was great being here. Thanks for having me, Michael.
Yeah, thanks. Talk to you later.
All right, bye-bye.
This has been another episode of Talk Python to Me. This is your host, Michael Kennedy. I want to say thank you for listening, and let's let Wikipedia take us on out of here.